Hello everyone, I am Sakshi Karegia along with my partner Vaibhavi Karya. We welcome you to our XR based COA concept demonstration. Today we are going to explore one of the most fundamental topics of computer organization and architecture, that is RISC versus CISC architecture. By the end of this presentation, you will clearly understand what RISC and CISC mean and how they differ and which one is used where in the real world. So let's quickly walk through what we will learn today. We start with understanding of computer architecture actually means. Then we move into the risk, what it is and how it works. After that, I will continue with the CISC and my partner will do the head-to-head comparison and look at real-world processors you already use in everyday life. Sees the performance comparison, and finally wrap up with the conclusion which architecture is better and why. So, what is computer architecture? Before jumping into the RISC and CISC, let us first understand what is exactly computer architecture. Computer architecture is basically the design philosophy of processor. It defines three key things. First, the instruction set, meaning what commands or operation the CPU is capable of performing. Second, the registers. These are the tiny, super fast storage locations sitting right inside the CPU itself. Third, the execution model. This defines how the CPU fetches the instruction, decodes it, and finally executes it. Now, our decades of computing history has two major philosophies have merged for designing the CPU. Those are RISC and the CISC. RISC stands for Reduced Instruction Set Computer. The core idea behind the RISC is keep it simple. Every instruction should only perform one basic operation, nothing more. Let us see the six key principles of RISC. First, simple instruction. Each instruction performs only single basic task. For example, just add two numbers or move a value. Second, fixed instruction length. All instructions are exactly 32 bits long. This makes decoding very fast and easy. Third, load or stored architecture. This is very important. In RISC, only two special instructions, load and store, are allowed to access the memory. All other operations must work on register only. Fourth, large register files. RISC processors have 32 or more general purpose registers. Since memory access is limited, you need many registers to hold your working data. Fifth, single cycle execution. Most RISC instructions complete in just one clock cycle. This makes the RISC extremely fast. Sixth, relies on compiler. The compiler is responsible for breaking the complex task into many simple instructions. The hardware stays simple and the compiler does the hard work. Now we will learn about the CISC. CISC. CISC stands for Complex Instruction Computer. Unlike RISC, the philosophy of CISC is do more with fewer instructions. One single CISC instruction can perform multiple operations at once. Here are the six key principles of the CISC. First, complex instructions. A single instruction can load data from memory, perform a calculation, and store the result, all in one go. Second, variable instruction length. Instruction can vary in the size from 1 byte to as many as 15 bytes. This makes the decoding more complex and more harder. Third, direct memory access. Unlike RISC, CISC instruction can directly read from and write to memory without needing separate load and store steps. Fourth, fewer registers. CISC processors typically have only 8 to 16 general purpose registers because instruction can work with memory directly. Fifth, multi-cycle instruction. Because instructions are complex, they take multiple cycles to complete a task. Sixth, layer. Since CISC uses a hidden layer called microcoder, which internally breaks the complex instruction into a smaller micro operations before executing it. Further, the comparison between both of them will be carried on by my partner Vaibhavikaria.
Thank you, Shakshi. Now let's put both of them side by side and compare directly. Starting with instruction size. RISC uses a fixed 32-bit size while CISC uses variable size ranging from 1 to 15 bytes. For instruction per task, RISC needs more instruction to complete the same job while CISC can do it in fewer instructions. Execution speed of RISC is faster and CISC takes multiple cycles per instruction, so its execution speed is lower. Register count RISC has a 32 or more registers, while CISC typically has only 18 to 16 registers. Memory access of RISC allows more memory only through load and store. CISC allows direct memory operations. Code size of RISC needs more instruction. The code size is larger. CISC code is more compact. Hardware complexity of RISC hardware is simpler and easier to understand. CISC hardware is much more complex due to its microcode. Power consumption of RISC consumes significantly less power while CISC consumes more power. This is why your smartphone uses a RISC based ARM chip and your laptop uses a CISC based Intel or AMD chip. Let's see. Now let's see where these architecture are used in real world. And I am sure you will recognize these names. RISC processor. The most famous example is the ARM Cortex series, used inside almost every Android and iPhone processor. Then there is Apple M1, M2, and M3. The chips inside that are of MacBooks, iPads, all ARM based RISC chips. MIPS architecture is widely used in common academic courses and used in network routers. RISC-V in an exciting open source RISC architecture growing fast in research and embedded system. And IBM powered processor are used in high performance servers. CISC processor. The most dominant is Intel 86 and 8664, used in almost every desktop and laptop computers. AMD Ryzen and EPYC are also 86 based CISC chips for consumers and data centers. The Intel Core i3, i5, i7, i9 family, the processors in most Windows laptops are all the CISC. So essentially, your phone runs the CISC while your laptop runs on the CISC architecture. Looking at the performance chart, we can clearly see the differences in execution speed and pipeline support. RISC scores a perfect 10 because it's simple. Uniform instruction allows CPUs to pipeline them extremely efficiently. In power efficiency, RISC again dominates with a score of 9 compared to CISC is 5. This is why battery powered devices always prefer RISC. In hardware design simplicity, RISC scores 9 versus CISC 5. However, code simplicity of RISC, meaning how the impact compact and easy the code is to write, favors the CISC with a score of 9. Since once CISC instruction can replace 4 or 5 RISC instruction. Overall, RISC wins on performance and efficiency while CISC wins on the code compactness. Now let's show the concrete example to make this crystal clear. The task is simple, multiplying two numbers stored in the memory. In RISC, this requires four separate instructions. First, load R1 from memory address A, then load R2 from memory address B, then multiply R3 equals R1 times R2. Finally, store R3 back to the memory address C. 4 instruction, each simple, each one clock cycle. While in CISC, you just write one single instruction instead of writing of 4. Multiply address C equals address A times address B. That's it. One line, but here is the catch. Internally, the CISC processor still breaks this into the same 4 micro operation using its microcode layer. The programmer writes less, but the hardware works just as hard underneath. This perfectly sums up the core difference. RISC keeps the hardware simple and lets the software handle the complexity, while CISC hides the complexity inside the hardware to make the code shorter. So, which one is better? The honest answer is neither is universally better. Each architecture excels in its own domain. Choose RISC when you are building mobile or battery powered devices, embedded systems, energy efficient servers, or anything where power consumption matters. Choose CISC when you need a desktop or laptop computing power, compatibility with legacy 86 software or general purpose high performance tasks. And here is the most interesting fact. Modern processor actually combines the both. Apple's M series chips and Intel's modern core processor internally use RISC like micro operation even while maintaining a sys instruction set on the outside. So in reality, today's chips are a smart blend of both the worlds. This brings us to the end of our presentation. To quickly summarize, RISC focuses on the simplicity, speed, and power, efficiency with many small instructions, while CISC focuses on powerful single instruction and code compactness to the cost of the hardware complexity. Both have shaped the computing world from the phone in your pocket running ARM to the laptop on your desk running 86. We hope this demonstration gives you a clear and visual understanding of RISC versus CISC architecture. Thank you so much for watching. We are Vaibhavi Karya and Shakshi Kadegia signing off.